Yeah.
So this week we're kind of building on the past few weeks again, but we're going to focus more into the theory of evolution and talking about that. And then I think it kind of gets summarized here on this page as, can Darwin's theory of evolution be scientifically refuted? And we've had enough conversations where I think everyone in this room would say yes, but how do you articulate that? What are the fine points? What are the counter arguments? Those sorts of things. But to really do that, we need to understand what the theory is at its essence. So how would you guys define the theory of evolution, or Darwin's theory of evolution?
Hogwash.
Wasn't his theory the survival of the fittest?
Yeah, that's a
the
component.
birds that had the right beaks or the right wings or whatever.
Yeah.
Those are the ones that passed on the traits. And
Yeah.
wasn't he breeding pigeons or something? I don't remember. I mean, there was his finches or whatever, right? But didn't he also breed something like on his property?
Yeah. I don't recall that exactly.
Lies.
But then there was some island with finches or something.
Yeah. Galapagos. Yeah.
Oh, well, I would just say he's a whole lot of times that actually bring things together. It just doesn't make a lot of sense, because the gradual stuff it doesn't hold water when you look at everything that has to exist at the same time to even make life. And so, in random, like you said, hogwash discuss. I mean, there's nothing random about the process, and that's all you're doing is just changing words, definitions of words, to try to come up with some plausible explanation for something, for a whacked theory.
Yeah.
But so
I think there's elements of truth to it. You know, like
the randomness.
Like certain traits will help you survive, and those will get passed on to your children.
Oh, well,
Like, and that's true. Yeah. But like, it gets wrapped up in a bigger theory, which doesn't work.
Yeah.
And because it's truth mixed with fiction, it's more believable.
Yeah. Yeah. Usually that's described as macro versus micro evolution, right?
Yeah.
Like microevolution we see all the time, right? Like bacteria adjusting to their environment, or the beaks on the finches, as Darwin observed, or all the varieties of dogs that are come about from selective breeding. So we have that micro aspect, but then again, like you're saying, like the macro side, it's hard to see how that comes about. How does those change? So if you think back to the last week, we were talking a lot about DNA and genes and how they functions, and you had those letters. So when Darwin's first theory didn't touch on any of that, because it just wasn't known, right? Darwin didn't know about any of that stuff. Like the cell was just it's cute as like this black box. Like in Darwin's age, it was like, oh, the cell is interesting. We don't really know about it. It's just kind of this little jello-y thing we can kind of see. But like that was it. That was all that was known about cells. And then when they opened this black box of the cell, they found all kinds of craziness. So in Darwin's day, there was, he coined the survival of the fittest, and it was all about the changes that came about that led to greater survival. They like passed on their genes, and like that was the main thrust of the argument. But then as the cell came in and we learned about DNA, Darwin's theory evolved, if you will, and that's what's usually called neo-Darwinism, which basically takes Darwin's general principles and expands them to like DNA and all of that. So they would expand on it, saying that there is random mutations in the DNA which causes minute changes in the organism that, if leads to greater chances of survival and breeding, then you pass that trait on. So if you remember last week, we talked about the letters of DNA and like how those functions work. So a mutation of those those amino acid, like the nucleotides in the DNA, like a change in those would result in a change in a protein. So like that is what we know. So then like that protein changes, and then that protein can come and potentially bring up like a new function, apparently. So like this theory really relies on these little changes, like, and like how do those mutations occur? Typically, it could be just like in like natural cycles, like something shifts, or like cosmic radiation like swaps damages the DNA and it makes it beneficial.
What about like I can't remember what it's called. I want to say dominant versus like recessive genes, right? Like if you keep breeding the dominant ones over and over again.
Yeah, I mean that.
Like
I
say, like they say, like eventually we won't have blondes anymore because it takes two people with the recessive blonde gene to make a blonde.
Yeah.
So eventually there won't be any anymore. That's what I've heard.
Yeah, I mean that sounds right. Yeah, like the whole like breeding aspect does come into play, and like, well, that's the other component that drives evolution that's talked about. I mean, survival of the fittest is part of it, but you also have the like more likely to breed aspect. That's where like evolution starts talking about like those birds with the fancy feathers. Like that has no survival benefit, but if it gets them a mate better, then they're able to pass their genes on more. And like that's, so like, you could look at blondes as that kind of way, but like the big fact that it's a recessive gene makes it harder to accomplish something like that. So there's a lot of nuances to how things play out. But like if we go back all the way out to the DNA, a change in the DNA needs to cause a change in the protein and the protein's function, and that protein function has to have some meaningful benefit to the creature. Mm-hmm. Like if it's neutral, there's no reason to keep that change. If it's harmful, it's going to be less likely to survive and mate. So only if it's beneficial and helps them survive will we expect that to be carried on. But we have these very tiny changes, and we're looking for these very macro effects, right? Yeah. So like there's this idea that like we kind of understand the DNA aspect and the protein aspect, and like we even know like certain genetic diseases are caused by specific genes making it malformed proteins, but like how that extends to like body plans and like growing a whole new arm or something like that. Like that is something that's still under investigation in science. Like they're not sure how that works, right? Like we know that DNA drives the protein production, but then it has effects on the body, but like bigger macro body plan, like certain aspects of our personality and all that, there's still a lot of gap there.
I assume it's also safe to argue minor changes in proteins tend to lead to catastrophic problems more than beneficial problems or beneficial attributes. Yeah, we're actually going to talk about that in detail here in a minute. But yes, that is true. There's actually been there's a guy. His name is Douglas Axe. And he's I think he's a fellow of Discovery Institute, or at least is very tightly coupled with him. But he's a working scientist, and he's written a couple papers on the plausibility of how likely is it that a functional protein would be created based off of the amino acids that make up proteins. So, the amino acids are the building blocks of proteins. And then like the DNA is instructions on how to put those amino acids together to form a protein. And then that protein has to fold up all together and then do some function, So he was like, how likely is it that a change in that sequence would be beneficial and create a functional fully protein?
So, like, I think we've the experiment or whatever has come up where they've taken made glowing cats and stuff like that. Like, I wonder if in that process of them doing that, do they come to the conclusion, or do they see where okay, we see how we did this, and there's no way that this would happen in nature.
Right.
So it's okay, so that would they even look at that and be okay, so our theories of this, squirrel turning into a giraffe over among it's we just made a cat glowing by splicing this from this, and we can see through that process that would never ever happen. If we hadn't intervened, that could not have happened.
Yeah,
I don't know if that's.
It's a good question, and I think this is my assumption based off of things I've listened to. I think most evolutionists, or even most scientists, because it's the general consensus still, it would say, we see it, so it happened somehow, materialistically. We don't know how exactly it happened, but obviously it happened because there's the giraffe. That's kind of where they go with it. They don't even.
Well, they have the assumption that they have 1 billion years to accomplish that.
Yeah. So,
over the course of 1 billion years,
until they figure out that 1 billion is not enough, so they'll just tack on a few more billion.
More zeros onto the end of that, right?
Or the multiverse in general.
That's it.
Yeah. No, I think. Well, I think they would again argue there's probably some mechanism that we haven't discovered yet, right? Which that's plausible. Maybe there's some crazy event or circumstances which makes that happen really easily. We just haven't gotten there yet. That would be that would be the argument against that. It's not. It's reasonable. It's just is that the best explanation that we have? And I think that's what we ultimately come down to. And that kind of goes to Stephen Meyer's main one of his main points is there's so much information in life that it's hard to explain with these naturalistic approaches. So what is the most likely explanation? What do we know that creates information? People do. We program, we write books, we create music, we have minds, we have reason. We take noise and make something of it. That's the attribute of a mind. And he's that's a more natural explanation. That is a explanation that it's a mechanism that we know about that does this effect. Why would we not consider it? And I think that's one of the primary and one of the best arguments for intelligent design that I've heard is you could say, there might be some mechanism out there that we don't know about, but that's unknown territory. That's almost, materialism of the gaps, as they, the materialists would say, God of the gaps, but really there's a materialism of the gaps where it's hey, there's some unknown thing that we don't know about yet. We just need to do more. And then we'll figure it out eventually.
Just a different name.
It's just a different. It's the same logical principle. And here, ideas hey, there's actually a cause of information that we know about that we see every day, and that is a mind. So why wouldn't we consider that is even a possibility? And I think that's the biggest thing in the scientific community today that just rubs me the wrong way. Is sure, I'm not going to say you have to believe that it's intelligent design, but at least give it credence as a plausible theory. When you can say, there's a multiverse out there with multiple universes and have nothing about it other than just some equations that you've made to work to kind of make it all fit together. There's just it just seems ludicrous that they wouldn't consider it a legitimate scientific theory, because it is. Why wouldn't it be?
Yeah.
So getting back to kind of Darwin and is evolution's, can we scientifically refute it? Darwin himself wrote, if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down. And that was from Darwin himself. He was like, yeah, my theory has an Achilles heel. And that Achilles heel is if a function cannot be explained by little progressive steps towards that over time, then my theory breaks down. And it's even harder than that, though, because if we go back to the effects of a mutation, right? So there's 4 effects of a mutation. It can be beneficial, increasing the ability to survive and or reproduce. It can be neutral, no change in the ability of the organism to survive or reproduce. It can be harmful, which decreases the ability of it to survive or reproduce, or deadly. It just causes death or sterility.
What is specifically a mutation?
So if you think of DNA in those letters, it's a change in those letters.
A random
change.
Yeah. What is O?
Yep.
Typically?
Yep. Yeah, because there's no, in the materialist worldview, there's no agency to plan those changes. So you're basically, you have an organism, a frog, let's say, sitting on a rock, and it's hanging out there, and a cosmic ray or a piece of radiation or something hits some of its DNA and corrupts it. And that corruption, spreads, and then it can have one of these 4 effects. It could be deadly, or it could be harmful, or it could be neutral or beneficial.
Are gingers a mutation? Let's talk about that on the podcast here. What's your official opinion on gingers and mutations?
I'm guessing that it's some sort of genetic anomaly. I don't know. Maybe it's just a genetic trait.
Here goes 1% of your audience.
Yeah. So we have these 4 effects. And you alluded to it, the vast majority of observations we have fall into the neutral, harmful, or deadly categories. Like you think about the genetic diseases that we have today, or the genetic disorders. There's a ton of them. And all of those come back to some mutation in the DNA that causes a protein to not work as well as it should, or not at all. And that causes effects. And sometimes those are annoying, and sometimes those are deadly. Very rarely, or it's like, there's only a few that I would even consider neutral. I don't know if you've seen Ripley's Believe It or Not, or this show's about superhumans or whatever. There's a genetic disorder that makes your tendons and ligaments more flexible. So they can they're the people that can bend their fingers back to their arm, and they have a lot of flexibility, which is kind of cool. And usually they in the past they would have ended up in a circus for doing all kinds of I don't know what that's called. Contortionists, yeah. They're just natural, they're genetically predisposed to be that way. But even that is actually can be harmful, because they're unable to resist certain things, and they have to be very careful about how they move, because the body has there's limits to your body. The reason why you can't just naturally do that is because that's an overextension, and your body's no, that's not going to be good for you long term. That's going to happen. So contortionists and people like that. I was watching a VFX show, and they talked about contortionists doing stuff in the industry, and they usually have to film it backwards. So like, the zombie movies when they're like all like messed up and they're like in some weird position because they got hit with a baseball bat or something. Like they have to start in that position and then come out of it and then reverse it, because if they try to get into a position like that suddenly, like it can do a lot of harm. Like they have to have a very controlled movement into that thing, just because their bodies don't have those limits to them. It's kind of like the genetic disorder where you don't feel pain, right? Like that sounds great in theory, but in reality, those people live very short, like they have shorter lifespans because they just don't know what hurts. So they like, they'll rest their hand on the oven and not realize that their hand is burning. And like, that's terrible. But like, they're just having a conversation and not realizing it. So those are like, neutral to harmful categories. And to get actual beneficial changes, it takes effort. So let's go back to the protein and how it works. So we talked like proteins are a string of amino acids, and then they fold into a three-dimensional shape. To get those proteins to do that requires a very specific sequence, right? Like if you have Legos or something like that, to build a certain structure, you have to put things in the right order. So that by itself makes it difficult. There is also like many proteins don't function independently. They actually have there's protein to protein communication that happens. Like two proteins fit together perfectly, and then like they do some function because they fit together. So that makes it even more difficult, right? Because not only do you have to make a change in the one protein, you also have to have a complementary change in the fitting piece. So like, how does that happen randomly? And then it gets more complex because many proteins end up forming molecular machinery. So they're just a cog in the greater machine. And, it has a specific role in that greater system of things. So you can see how this compounds. And like Darwin, like the chance mutations can explain, like we know that radiation can damage DNA and cause mutations. But what are the chances of those actually resulting in something beneficial? Very, very small. And this is where we get back to the Douglas Axe and his studies. He's a molecular biologist, and he's rigorously studied how rare proper folding of proteins are among protein sequences. He said, okay, so
is he somebody like current from
he's
today?
Yep. He's a modern scientist today. Discovery Institute's YouTube channel. He has quite a bit of he has videos on there, or videos related to his work. So yeah, he's a working scientist today. He studied a modest protein that had a length of 150 amino acids. So that's like a reasonably sized protein. It's not exceptionally long, and there's some shorter ones. It's probably on the below average side of it. So 150 proteins in length. So that means 150 amino acids in the right sequence. What he was like, what are the odds of forming a stable functional protein? So you have all the amino acid building blocks. If you put 150 of them in some random order, like what are the chances that it'll be some kind of useful protein? So the number he came up with is between 10 to the 64th and 10 to the 69th. No, sorry, it's 10 to the 74th. That's the number, 10 to the 74th. For context, the number of atoms in galaxy, so the number of atoms in the galaxy is 10 to the 64th is 10 to the 69th. So the chances of a functional protein coming out of 100 with 150 amino acids in length, the odds of that forming randomly are less than the odds of a blind person randomly picking a random atom in our galaxy. So pretty small, if not pretty much involved. It's like needle in a haystack times a million. Like every atom in the galaxy. Just the number of atoms in your body would be impossible. So the chances are very, very small. And you can fairly confidently say that the chances to get that from a random mutation or natural selection are impossible. It's just there's not enough time in the entire universe. Maybe, and if you have once you get into a multiverse, potentially you have enough time. Like it's an infinite scale, so everything that could happen would happen, but still, that's just for a single protein. So an example of a protein that you've probably heard of would be hemoglobin. So that's like the protein in your blood that carries oxygen throughout your body. That protein has, let's see, I lost my spot here in this.
So, sorry.
Yeah, no, you're good. So that protein is very specifically structured. So it has 4 oxygen binding sites in it, and there's been research done that basically any changes to that protein are fairly catastrophic. And there's genetic disorders around that specific protein, and most of them are deadly. But I think some potentially you can live on, but it's a very specific thing. So this protein function, it obviously is very difficult to get those changes. And then we talked about how that's just for a single protein, and then you scale that to protein communications. Now you've just, by a factor of who knows how much, made it more complex. Because now you have to have changes that are happening on both sides. And then you get to this idea that Michael Behe, I don't know if you've heard of him, but he's one of the, founding fathers of intelligent design, I would say. Especially his book called The Black Box, Darwin's Black Box. He coined the term irreducible complexity, which we've talked about in previous sessions, but if we dive into it more, how would you guys define irreducible complexity?
Irreducible? So you can't reduce it?
Right.
So it's the simplest form of complexity? You can't get any less complex than what something is in order to, be a thing?
Yeah. That's pretty much it. One classic example would be a mousetrap, right? Yeah. Like a classic mousetrap. You have the board, you have the spring, you have the bar, and you have the little piece that holds the thing back. If you took one of those parts out, you would no longer have a mousetrap, right? You need all of those bits for it to function as a mousetrap. So that is an example of irreducible complexity. It's a system that every piece is required for it to do its function. And there's so many examples of that in biology that, like, it's not even funny, right? Like the protein communications, right? Like those are, those aren't super complex, but they need those shapes, like it needs those puzzle pieces have to fit together. But then you start talking about, so one of the classic examples in biology is the bacterial flagellum. And so what is the bacterial flagellum? It is the tail, if you will, of a bacterium that helps it like move through in its environment. So it's like its fishing tail, like its tail. And we're talking a cell, right? So it's very small, single-celled argument. And these flagellums, when examined, are basically rotary engines. Like I don't know if you can see this picture here, but like it's a rotary engine. Like it has a shaft, it has a rotor, it has a U-joint, it has a propeller. Like these are all things that engineers, like we have reinvented this, right? Like for our boats. And for some cars have similar things in it, like the shafts, and like the fact that we have independently designed a similar thing that does a similar function, and then we find it in a bacterium is, I don't even know how to put it to words. It's kind of flabbergasting in a way. It's why would we find that? Well, it's because it's engineered, right? Like and this is where irreducible complexity comes in. If you were to, I think, was that down on this page? Okay, so there was some, there's a area of research called genetic knockout experiences, and it's basically how much genetic information can we knock out and make this thing still work. So this has been done with flagellums. And the flagellum fails to assemble or function properly if any one of its approximate 35 genes is removed. So it's an all or nothing thing. So it takes 35 genes. If you think back to a gene is a thing that codes a specific protein segment in the DNA. So I think this is correct, but it's around 35 different proteins that are being put together to create this flagellum. And if any one of those is knocked out, the flagellum doesn't function. So how did that come about in a systematic, small, changed way? How do you get all 35 pieces all to fit together and all be put together correctly in a systematic, evolutionary, explainable way?
Darwin wasn't able to see things that small when he came up with his theory.
No.
So it doesn't even seem like it's even
possible.
a thing anymore, especially being able to see things that we're able to see these days.
But is that concept scalable? Like, so in this like micro example, like Darwin wouldn't have been able to see that, but the truth of the problem, maybe this particular mechanism, we wouldn't scale that, but you can still take the truth of that problem of like, if any of these things had gone just away, that reality could be scalable to where, like Darwin or we could observe that this is ridiculous to make this claim that this could happen this way, because it's like it just doesn't work.
Yeah, I think what happens with scale is as you get into like what Darwin could observe, there's a lot more assumptions, right? Like, so Darwin just saw cells as little goo balls, and like he's like, he observed microevolution and he just projected that forward, which is reasonable. it's not unreasonable to think that. He's like, oh, well, if these birds' beaks can change based off of the food that they're eating or the food supply, if you give that enough time, maybe a bird can turn into something else. Because, if they can lead to small changes, then why couldn't it lead to bigger changes?
Sure.
And that's reasonable. But when you start getting into so with I think what's interesting about the flagellum is it's something that we can see. It's a much more simplified example, right? We there might even be chapters on this in the future, but we don't really understand how DNA affects body plans or bigger multi-protein examples, right? We can say, okay, genes affect proteins because that's what they code for. But how do proteins tell the cells in an embryo how to form the body? We don't know is the answer. And there's a lot of research going into that to try to figure it out. And presumably there's some explanation that we don't know about yet.
Well, as far as the changes that they either kill or do nothing or all that kind of stuff. So it would seem like there's at least some sort of changes that are either neutral or because otherwise we would all look the same and we would, if everything's put together in such a way then everything should be the same. But there's apparently and obviously and we're all reasonably healthy and all that kind of stuff. So it seems like there are. There's a ton of variation, but yet, so I don't know.
Yeah. There's a range in organisms, right? Different organisms have different ranges. Obviously, dog breeds. Wolves gave us a huge variety of dogs. You have Chihuahuas and wolves, and everything in between. And then humans, we all are unique in some way, and we'll have different. So there are what seems to be operating limits that make sense, and how that happens is still not very well understood. But with this flagellum, we can see all the proteins that go into making it. We can say, okay, look, these are the genetic markers that mark for these proteins, and if we damage one, the flagellum doesn't work. So it's a much more tangible thing than I turn off. It's today in science, you can't turn off a gene that makes it so you don't grow arms, right? It's much more complicated than that. Arms are not. There's not a protein arm correlation that we have found, where there is a protein flagellum correlation that we can see. So it's this, it's part of the story of life that we can see in a more knowledgeable way, right? So there's less assumptions. And I think the fact that itself is so phenomenal. The things we don't understand have to just be even more so, you would presume, right? If we can't even explain how DNA gives us arms and legs, it has to be something pretty advanced. It's a very complicated story. Whereas the flagellum is a much more simplified organism, but it's still amazing. It's engineered. Speaking about the flagellum, so it's a self-assembled rotary engine. The motor is driven by a flow of protons, which is pretty interesting and worth looking into. It spins in two directions, forward and reverse. It can change directions in a quarter turn. It operates around 18,000 RPM and can spin at 10,000 plus RPM. Over 30 genes produce over 30 structural parts. According to one study, it might have up to 100% energy efficiency, which is something we have never come close to. So it resembles things that we've done, but in a lot of ways, it's vastly better. Which is just crazy. It's we think we're pretty smart at engineering. Like we've engineered some pretty amazing things, but the tail of a bacteria is blowing out of the water our best and finest engineers. I mean, that leaves you scratching your head.
Sure.
Okay, so Darwin's Black Box. If you haven't read it, highly recommend it. It's like it's the book that like put ID on the map as like a legit scientific conversation.
Who wrote that?
Michael Behe. Yeah.
I've heard of him.
I
So-
sent you a video of him
Sounds like
landing some iron.
Oh yeah, that's where I've heard.
Yeah.
Yep.
Yeah.
And that was an excellent video.
Oh man, those are some good minds all together.
Yes.
Every time you say his name, I just think of Michael Jackson.
Well, now you won't forget. Okay, so that book comes out. The scientific response was, mostly like, oh wow, that's interesting, but evolutionists obviously were like, nah, that's not. They needed a rebuttal. So they went back and they basically came up with this idea of co-option. So co-option is evolutionists' counter argument to irreducible complexity. And the argument basically goes like this. Co-option is to take and use for another purpose. In evolutionary biology, it's highly speculative mechanism where blind and unguided processes causes biological parts to be borrowed and used for other purposes. So basically the idea is this. So let's take the flagellum as an example. There are parts of the flagellum, and they're saying to get to that irreducibly complex thing in a series of small changes, what could have happened is the individual parts could have been used for other things in a lower with less complexity. So let's say the shaft protein, whatever that is, it was used for some other purpose, and the rotary part that was used for some other purpose, and so they have these simpler parts were used to make other systems, or excuse me, they were used they were used for other things, and then they eventually were like, oh, we don't need that purpose anymore, and we're going to all kind of come together to form this rotary flagellum.
They saying randomly on their own or by an outside force?
This would be natural processes only. So
the tail was used for something else, and the engine was used somewhere else, and then
and then like you can have
moved to a new
multiple
location.
steps of that, right? So like the tail could have been like a shorter version that was used to move something around inside the cell. I'm just making stuff up, but like it wasn't necessarily like the final part was there, but like some simpler version of that part had some other use.
So it's bashed.
So I can take a desktop computer, rearrange the parts, and make a laptop.
Yeah, something like that. Yep. And that right there gets at one of the counter arguments to co-option, right? You could put all the pieces of a desktop computer in a box and shake it and never get a laptop, right? Because the order and the assembly of those parts requires instructions. Where do those instructions come from? Like, that's information, right?
Mm-hmm.
Like, you need to know that the hard drive plugs into the motherboard, and you need to know the power supply goes to this certain plug. Like those are things you need to know in order to do it. And the question is there a natural process that can assemble things that way? And the evolutionary argument was like, yeah, if you get enough time and you have the right circumstances, maybe the hard drive got plugged in and like that formed some kind of useful function. And so like they can kind of spin it to where it works, but like it's it's theoretical, it could work sort of situation, not it's demonstrated to work.
It still begs the question of agency, though. Of
Yeah.
and then so yeah, you shake the box up, and maybe you don't get a fully assembled computer, but you do happen to get this, happen to plug into this. But then what makes nature, or whatever it's going to be called, to say, hey, let's keep doing that?
Yeah, exactly. There's a lot of the way evolutionary proponents talk about it. It sounds plausible on the surface. Like, okay, yeah. Sometimes, the eye is sometimes used as an irreducibly complex organ. Example, and like that's been I think it might even be in the Behe's Black Box book as an example. And evolutionary biologists have come up with a pseudo-plausible explanation of how that could happen, right? That explanation goes something along the lines of somehow a cell got a mutation where it became light sensitive. So it wasn't like an image or anything like that. It was just sensitive to light, and that cell multiplied and got hooked up to the brain, so that something like a tardigrade or some really tiny simple organism was able to say, oh, if I move towards the light, I get a better environment. And like that was the foundations of the eye. And then as
how is that thing able to decide what is and isn't better, right? Like,
well, and it according to evolution, it doesn't. It's just like, oh, this is a helpful bonus now that I have as a new baby version of this.
Yeah, but it's still like, what does helpful mean? And what
yeah. Well, I think that goes back to it makes you survive or reproduce more.
All right.
Because like that helpful is defined that way. It's like, oh, it makes
by whom, by what, and like how does this barely multi-cell organism able to even without farther thought, come to some form of conclusion to whatever level that this is what is helpful, what is unhelpful, why is it, so then maybe we're getting more into the philosophy of it. But
well, like it's like, okay, the light receptor. So like let's say it's an algae eating bacterium, and it has a light sensitive component to it. If it moves more towards light, maybe it finds more algae and then can eat more and then produce more. Like that's how they would explain it. Like I do think there are things of what you're saying that are true, but it's like that's often what you find is like you can create plausible arguments, but like demonstrating those is a whole nother can of worms that we usually don't get. Like you see the same thing for things like, how did humans first evolve the ability to communicate, like language? Well, and they have certain things like that they can explain. Or how did dogs become domesticated? Like there's evolutionary co-evolution sort of theories on that. And they're very plausible, but like the mechanisms that drive them aren't clearly explained. They're just like, this is plausible, like it's nothing scientific. And that's where I go back to like the materialism of the gaps. Like it's like, yeah, this could kind of happen if you think about it, but we don't really show the mechanisms of it happening, so it's kind of on faith.
Sounds like you need a mind. No matter what way you look at it, you need the mind before any of this could ever possibly.
Yeah. And it goes, and again, we're back to that argument of like, what's the simplest explanation for what we observe? the only thing that we know that creates this kind of information is a mind. So therefore, a mind did it. Like that's a very simple argument. So all of this to be said, like, it's frustrating that the materialistic paradigm in science is so against these things. It just doesn't make sense. It's not really in the spirit of what science is, because who's to say that it's any, like, it's a very good explanation, and you don't have to subscribe to it to say it's a valid theory, but that's not how it usually goes down. Usually intelligent design is, like, if you look up intelligent design on Wikipedia, it describes it as a pseudoscience, which is basically like, it's not a grown-up science. They can dabble. It's not really legitimate. It's just pseudoscience.
You should log in and change that.
I'm sure people have tried. But yeah, that's the way it's looked at.
WHO says chiropractic care is a pseudoscience.
Yeah, I believe that. So
let's go stir the pot a little bit with that. I told that to my chiropractor once. He didn't care for it.
And then he's like, the joke's on you because you're paying me.
That's right. That'd be $40.
Yeah.
So let's think back to the opening question. Can we scientifically refute evolution? And then to do that, like maybe some questions around that, more specific questions. Do you think there are any explanations thus far scientifically that explains a cell's complexity sufficiently?
You say that one more time?
Do you think there are any scientific explanations on why cells are so complex?
So we started off by kind of going over what is evolution. So maybe let's redefine or whatever. Like when you say, can you do this scientifically? Like what's meant by scientifically? What's the requirement to count as like,
I thought the same
is,
thing.
Yeah.
Like, isn't science just what you can see, hear, and feel? So everything is science.
Right. Like I know that there is a scientific method, and I know that evolution is supposedly a thing, like a defined, but those are words that are used so freely that, and without definition, that a lot of argument comes from, you're using it this way and I'm using it this way, and we're both assuming that we're kind of using it in sort of the same way.
Trust the science, okay?
Yeah, it's
Trust the science.
So for the sake of maybe at least this conversation, like what's meant by scientifically, can you blah blah blah. So what's meant by scientifically?
Yeah, that's a great question. How would you guys answer that question?
Ooh, answering a question with a question. Very Socratic.
Yeah.
You a politician? You running for office?
We've moved into the discussion phase of so
I don't think we know or understand why or how it works completely. I think that might be what you're...
For the definition of science and something.
I don't think we know it with this, 100% how everything within the body works and how it works and how it came to be.
Right.
Yeah.
I think it's all theory.
Mm-hmm.
So you can. So part of it, I think, with the scientific stuff, like where you have, so you perform an experiment. Well, the test of the validity of that experiment is peer review, and so can it be, repeated and reproduced and all that kind of stuff. So, for the sake of, if we're going to say for the sake of this conversation at least, and you would hope it'd be more universal, because isn't that supposed to be the thing with science, is that it's universal, even though it doesn't seem to be used that way. We could say, okay, for the sake of this conversation, scientifically, the parameters to justify it or to count as scientific is is there a peer-reviewable, repeatable, experimental environment where we can test parameters and then reproduce it, or I guess something like that.
Yeah. Yeah, I mean, I'd say you're along the right lines of thinking. And like your question gets at a whole box of thought, right? Like defining what science is a very difficult thing for even scientists to do. Oftentimes you hear things about the scientific method, like what are our modes of sensory input, like our test instruments and like our physical senses. And it quickly comes to one of the founding principles. So science is built on top of philosophy. So philosophy was kind of like the first science, if you will, like which, philosophy is the art of understanding and rational thought. Like, can we think through things? What does it mean to think at all? Mm-hmm. And what can we trust in our senses? Like, those are classic philosophical questions. And the what is science quickly gets into this big, muddy, philosophical, untangible, like very interesting, but hard to nail down thing. So oftentimes you hear science as, the process of the scientific method and then backed up by peer review. And then you've got scientific data. But that's not where science stops, because it's not like scientists say, here's my data, the end. They draw conclusions from their data, right? Like that's, a fundamental part. It's like, oh, we observed X, so that means Y. And that so means Y is where evolution fits in, right? So you go back to Darwin and the finches. He observed the finches having very beaks based off of their food supply. So he concluded that environmental and survival aspects would select for specific traits, and that over a significant time, which like that first part was observed. So I would say that lands under science, right? We have observed things changing to adapt to their environments. The question is, do things change to become new species? And then that begs the question, what is a species? But do birds turn into something fundamentally different? And what does that mean? So there's parts of evolution in Darwin's theory that I think do fall under science. I think where it gets more difficult is in that, is it an explanatory, does it explain everything? No, it doesn't. And that's why it's a theory at the end of the day, is because it's not been proven. And science has had almost 100 years to prove evolution on a macro scale. And most scientists will, this is a guess, I would say if you polled most scientists, most would say that the scientific theory of evolution is most definitely true, almost certainly true. But if you go to the data, if you start looking at the data of there's been lots of studies around biology and the study of life and how things evolve, and some of it is being used to understand population growth and all this kind of stuff. But if you look at have we observed things changing species? No, we haven't. We have not seen that sort of thing. And you're well, we just haven't had enough time. But the thing is, for bacterium, you can get hundreds of thousands of life cycles of a bacterium in a short amount of time. So there have been studies trying to evolve bacterium to have specific traits. And they've been pseudo successful in the sense that I can't remember the exact details of the story, the exact experiment, so I'm going to kind of make it up a little bit, but it's along these lines. There's been studies where they've taken like bacterium or yeast cultures and tried to expose them to, like ammonia, which should kill them. But they, start out with low doses, and then they build up the yeast culture's tolerance to ammonia, and they're like, hey, look, this is evolution, or is it adaptation to their environment? Because what ended up being the results of those studies, and I'd have to go look exactly what the study was, so don't take the specifics, but like, it ended up turning out that, it got more adaptable and was able to live in more ammonia-filled environments, but at the cost of, some specific other aspect of it. So it wasn't straight up beneficial change. It was at the cost of some other change. So like, there's another more recent book by Behe, and I'm blanking on the name. Maybe it'll come to me before we end. But he talks about this idea, and this is what I subscribe to. This is a little bit of a tangent, but within a species, or, let's use the biblical term because I think it's even more helpful here. Within a kind, there is a certain range of adaptability in that kind. And we see that in this book. He gives an example, and I may have mentioned this before in other classes, but he gives the example of polar bears. So polar bears are, very similar to black bears, and they have some specific mutations that make them more adaptable to cold environments, and they're very specific They're actually very specific genetic changes. Like one of which makes the bear able to digest fat better, because like a polar bear's diet is like seals, which are like all fat. They're just like fat balls. So
I identify with that.
Yeah.
I'm making t-shirts.
So the bear can digest and use more of that fat. Another one is like around their fur and their coats. They have special adaptations. I think like their hair is hollow, so it's more insulative. And like those are specific changes. And like we can trace those down from the bear kind, and we can see that the polar bear has been adapted to these cold environments. The thing is the changes that resulted in the polar bear, although the changes were beneficial for the creature to live in an environment, they were ultimately destructive in nature. So the proteins that were changed performed worse. Like they were like handicapped in a sense to result in these adaptations that were beneficial. So like it's this weird combination of like specification in like you have this kind with all this potential, and then the kind gets put in specific environments and it like shrinks its potential, and then it gets more specified and it shrinks in potential. You can see a similar thing in domesticated dogs, right? Like you have a wolf and it has this certain wide range of adaptability, way huge differences in size and stuff like that. But when you get a Chihuahua, you can't go from a Chihuahua back to a wolf, right? It's one directional. And that's because it's corruptive in nature, but it's too specified for a environment and adapt to an environment. So this is the kind of view that he paints in this book. So like there are aspects of evolution in that are true, right? Things adapt to their environment, and survival of the fittest applies. So like you get a polar bear that was slightly better at digesting fat, lived more, and was able to reproduce more. So then that gene got carried on, and now you went from a black bear to a polar bear. The thing that's harder to explain is kind-to-kind jumps. Like that is something we have not observed in scientific data. So getting back to the original question of like, can science explain these things? I would say it can explain some things, but not everything. And then like scientists use theories, and I'm going to use materialism of the gaps to say, it's plausible. It goes back to their fundamental worldview. And this is also getting back to philosophy, like a materialism tenet that everything, like there's this idea in the scientific community that if you can't explain it materialistically, it's not science. But is that a tenet that should be part of how we define science? I think that's at the root of the intelligent design and science rift, or even religious and science rift. Scientists are like, no, we can only stay within this materialistic worldview because that's what we can test, that's what we can observe, and I think there's some argument there. But science often crosses the line into philosophy.
But so, yeah, from science, the material is the only, but like, is it the only thing you can test? Because like Scripture tells us to test the spirits, and Scripture tells us to, test against, so it's like there's this exclusivity that's been fabricated between the material and the spiritual, and even though that doesn't really exist, like we live in a material and spiritual world, and so there seems to be there's separation, but at the same time they're not. I don't know that we have the capacity. Like, I don't know. Like, we can experience some aspect of the spiritual certainly seems to be more limited in our experiential understanding to the physical, but at least at this point, and then in the new heaven and new earth, maybe we'll be able to understand both perfectly, whatever that's going to look like. Who knows?
Yeah, I think that's another good philosophical question, because it comes down to what can we measure and observe, right? So I think we can kind of like we feel the Spirit working, but how do you tangibly measure or describe that in some way? Like that's where it eludes science, right? Like you can't nail it down. Like we don't have like a spiritual radar, right? Like it's much more. It's at least from my perspective, it's a much more different thing. Like you said, like it's this other realm, if you will, that like we don't have instruments to detect.
Almost like an unseen realm.
It's like that, yeah.
Almost. We should probably hear more about that.
Yeah, because like I think if someone invented a unseen realm detector of some kind, would the scientific community then more openly adopt that realm? It's like, oh yeah, now we can measure it. Now it even like becomes material. Like,
right. That's
the definition of material, is something we can experience directly and foundationally. So then does it even really be, is it even spiritual anymore? Like I think like there's this purposeful separation between and this is philosophy, this purposeful separation between material, what we experience in this realm that we are in, and this thing that we vaguely have intuition about, that we just can't, it's what theology has been after since the start of mankind, that we have in our souls to some degree.
It's almost like someone put eternity in our hearts.
Yeah. It is like that.
Who was it? So who was it that said way back in the day that philosophy is the mother of science and theology is her? It wasn't that long ago when philosophy and theology were like they were almost inseparable, like at the collegiate level and everything. That's
how universities started,
right? That it was just like, well, yeah, of course we're going to have philosophy and theology together.
Yeah.
They're different, but yet they're inseparable.
Yeah, and even science was in that. Like,
Right.
like that was all the same thing, and it's split into that. And I think that's where scientists become uncomfortable because they have ignored that side of the realm. They're like, we can't measure that. We can't do anything with that. We can do something with this. And so they form their theories based off of these assumptions that other side doesn't exist. So you have to come up with things that materialism of the gaps, because how else do you explain it?
It reminds me of the story of the guy who, whatever long ago, he figured out that doctors that were washing their hands weren't killing their patients as much. So he's like, oh, there's something like invisible, that's killing these patients, and you need to wash your hands. And everybody thought he was insane.
I think
because they couldn't see it, they couldn't measure it.
If Chelsea was here, she would know exactly. Yeah. I think it might have been John Lester, like Listerine guy. It might be that guy. At least I know. So the Listerine guy, like the company that started Listerine, like the guy who started it was fundamentally he was at the heart of germ theory and like understanding that. So he created a huge mouthwash business and also, saved billions of people with understanding germ theory. I wish Chelsea was here because she'd be able to go on about it because she loves that stuff. But,
It's amazing.
Yeah. And so irreducibly complex systems require a lot of components to be in place at the same time in the same order to function. We talked about this a little bit, but how does I think irreducibly complex, the idea of irreducibly complexity makes sense to people, right? Even this, microphone sitting on the table, I could only take a certain percentage of the parts off of this before it would just, there's a point where it's functioning and then not. There's not this gradual decrease in functionality as I take parts off of it. It's just on or off. There is some amount of critical components that would make this thing so it's the least amount of components and it's still functioning. And that's the idea of irreducible complexity. And we talked about co-option being a counter argument. How does that rate as an argument in your guys' mind after talking about it? The idea that these parts for this microphone could have been used for, this chair, and then, they got repurposed into a microphone.
I would go back with, since I heard the argument with BB and Meyer and Linux when they were talking about it, I'm going to go back to the actual mouse trap. It's the lever that holds down the trap. You can't actually replace that with a hammer and think it's going to work. The parts have to fit exactly.
Yeah.
So that's what boils down to irreducible complexity. You can get parts that look like it, but if they don't fit, it's not going to work.
Yeah. You have that aspect of it, and then you have the whole the assembly instructions. Where did they come from? I think those are two really strong arguments against co-option that science really doesn't have an explanation for. Because like I said, the idea of co-option, I'm pretty sure, was a result of Behe's book on Darwin's black box and this idea of irreducible complexity, and evolution's well, that's a pretty good argument. We should probably come up with a counter argument for that. And they came up with irreducible or co-option, and it's a plausible argument. It's just not demonstrated scientifically. I think they're working on it, and there might be studies out there that show some forms of co-option kind of in play. I think I've seen some of that, but it's it's not very solid, I would say. There might be aspects of it that are true, like evolution, but does it explain all of the nuances of it, like the bacterial flagellum that we talked about and how it comes together? Seems unlikely that those parts were useful, because like that's the thing with evolution is it's a bunch of small steps towards a change, but every small step has to be functional and beneficial for it to pass on to the next stage. And you need many changes to do anything meaningful, and they all have to be in the beneficial range. It's like kind of like flipping a quarter, or maybe it's like rolling a 100-faced dice 1,000,000 times and needing the same number to come up. Like it just doesn't make sense, because every single time you roll that dice, you need it to be that number, and if not, it's detrimental and you die. Like you're not going to have very many organisms surviving if that was the case. And that's just one change, and like the number of changes needed are astronomical. Like so many, and like we mentioned earlier, we don't even really understand. Like we understand the some of the parts on the DNA, protein machines, molecular machines, that we understand kind of how that works, and not super well, but kind of. But then, like, how does that translate to macroorganisms? We have no idea. Like it just doesn't. What I think is interesting is the whole body plan idea. Like, where does that come from? Like, how does that work? Science doesn't know. Like, because the DNA seems to code for proteins, not body plans. You know, it's just building proteins. How does it know to put my liver where it needs to be? How does it know that all my arteries need to hook up just right? There's no explanation for that. And like, that's even outside of any of this. That's just a whole nother problem that we are just clueless on. Yeah, it's pretty fascinating. As we close up, any other thoughts or questions come to mind? All right. Well, let me close this up in prayer and we'll call it a morning. Father, I just want to thank you for this discussion. Thank you for your amazing creation and the engineering that went into it. We still, as we learn more and discover more, and we see the just amazing engineering that goes into something as simple as a bacteria's tail, it's awe-inspiring. We think we are so smart and that we have built all these amazing things, which is true. But when we compare them to life, which is your creation, they pale in comparison, Father. And we just thank you for those signs of your fingerprints in nature, and we stand in awe of you and your glory, and thank you for all that you have done. Just pray that you would bless the rest of the day and this weekend, and thank you. In your name I pray. Amen. Amen.